Chris Kovalis, and I'm presenting in this year's IYQ tournament, and I'm going to present a problem called Moire for the counter. So I'll start. Okay, so I'll start with the problem definition. When a pattern of closely spaced non-intersecting lines, so parallel with transparent gaps in between, is overlaid on a piece of wooden fabric, then characteristic Moire fringes, so this pattern, so may be observed, and we must design an overlay that allows us to measure the thread count of the fabric. We must determine the accuracy for simple fabrics like linen and investigate if the method is reliable for more complex types of fabric, for example, denim or Oxford cloth. So I'll start with Moire patterns, the definition of the Moire patterns. A Moire pattern or Moire fringe, it's the same term. They are large-scale interference patterns that are produced when an opaque ruled pattern is with transparent gaps in between is overlaid on another similar pattern. But for the Moire interference pattern to appear, the two patterns must not be identical or identically aligned, but rather displaced or have slightly different pitch or rotated. Okay, so here is a mathematical expression about the Moire fringes. Because we're talking about some non-intersecting lines with certain distance between them, so we have two trends here. This is the first, the left trend. Here are some lines that have a distance of, let's say, D1, and here is another pattern with a distance of, let's say, D2. So as you can see, they start from the same points, on the upper points, and then they meet again right here. Given that this distance is D1 and this distance is D2, we came up with this formula which tells that the total distance between, they do not meet for the first time here, they have met also here and here. So the formula that gives us at the time that these patterns will meet again is that one, D equals KD, so K is a number, an integer number, and that equals to K plus 1 of D of upper D, so D2. But this one in the formula is just an example. We could also use 2, K plus 2, K plus 3. It depends on the form of the two patterns. So K plus 1, K plus 2, whatever. We just transform this formula and we come up with this, which tells that the distance between the places where those patterns meet equals D. You can see that here. And so if it was K plus 2, K plus 3, the only difference would be that in the denominator we will have like 2 dd, 3 dd, and so on. Okay. Okay, because we came up with this formula, we can see that when the distance is D1 and D2, or when these distances are almost identical, then the denominator becomes almost 0, so D becomes infinite. And as you could see in the previous example, here where we have a closer spacing, so D1 is closer to D2, the Moire fringes, the resulting pattern is more strong, and here it's even stronger. The formula gives us that when the two distances are very similar, the Moire fringe will become infinite, and that's the case how we designed our overlay. So you can see some convergent lines here. They have a different distance, and so when we place that on a fabric, we're going to have 40 threads per inch at 40 threads, where the two distances become equal. So 40 this distance and 40 the distance of the threads of the fabric, then we have a very strong fringe. But I think the image isn't displayed here on the screen, but you can see a very strong Moire fringe here. Okay. So this is our overlay. We have a range of 30 threads to 60 threads, and we have again some convergent lines. About the thread count, so in the fabric industry, the thread count is defined as the number of threads in a square inch. So we must count both the horizontal components, the warp, so the threads in the horizontal direction, as well as the web threads in the vertical direction. And so the sum of this thread count gives us the total thread count, at least as it is used in the fabric industry. So the method that we use is that we computed first the warps and then the webs. And then we added those, and that gave us the total thread count. Okay? But I would like to talk about the importance of right placement. So here you can see we used a pattern of lines that have a distance of 44. So there's 44 lines per inch, and you can see that a Moire fringe gives us indeed the right distance between them, the right thread count at 43. But if we that was because we perfectly aligned or overlaid with the alignment of the lines. But if we displace it, then you can see that there is no characteristic Moire fringe. There is no strong thing that will tell us that it's at 43 threads. So we must align it perfectly with the type of threads that we want to measure. Okay, so we performed our first experiment on linen. The measured thread count was 40 warps and 40 webs, so 80 thread count, and the actual thread count was 80, so the relationship is equal. There is total accuracy. Second experiment, Marco, so the measured thread count is 47 plus 47 is 94, the same as the actual thread count, so again the relationship is equal. Our third experiment is cotton, so we have 42 and 42 equals 84, but 84 and 84 give us 168 thread count, which is doubled, the measured thread count doubled. It turned out that this is a consequence of the range of the overlay, because our overlay has a specific range. It can only measure, for example, every second thread in this case. So we will have, we should have an overlay that has a capacity of maybe 50 to 90 threads count, so that it will give us the right 84 in this case. Okay, so there are some more complex fabrics like the Oxford cloth. As you can see, it has a horizontal and vertical component, but there are some prominent lines, there are some prominent diagonal lines. So there are lines like that, and this is what the human eye sees first. So we did an experiment on the Oxford cloth, and we had a measured thread count of 33 and 33 equals 66. But the actual thread count is 46 plus 46, 92. And the relationship is about the square root of 2 times the measured one. And we would like to give a geometrical explanation for this inaccuracy. So as you can see, here is a modeling of the Oxford cloth. Let's say that this distance is x inches, and this distance again is x inches. So the actual thread count is 1 warp every one warp every x inch, and 1 weft every x inch. So we have 1 to x warp and 1 to x weft in every square inch. So the total thread count is 2 to x. But the measured thread count is the most prominent lines here. These are the diagonals, the most prominent lines. And in this case, we have 1 warp every x times square root of 2 inch. We did that using the Pythagorean theorem in this triangle here. So we have 1 weft every x times square root of 2 inch, and 1 weft again times every x square root of 2 inch. So the total is 2 to x times square root of 2 inch. And it indeed gives us this geometrical approach. This gives us the thing that we found out here, so that the relationship is about the same as the square root of 2. Then we did an experiment on the denim fabric. Measured thread count was 23, the actual thread count was 34. The actual is 1.2 times the measured one. That was a strange observation. And here we Yeah. Okay, so here you can see an image of a Jenny. Measured distance is black because we want to count these threads, the warps and the wefts. But actually, the most prominent lines are the diagonals. So the measured distance between diagonals, the black, is different than the actual distance, which is the purple, for example, in the wefts. But without more information about the way in which the fabric was woven, we cannot determine the mathematical relationship because this distance between the most prominent lines would be different according to the way the denim was woven. So there is no geometrical formula that would allow us to predict the actual thread count in the denim from the measured one. Okay, so here are our conclusions. Our overlay enables us to measure the thread count of the fabric with high accuracy in most cases, provided that the actual count is within the range of our overlay. So our overlay would be mostly accurate, given that we are within range. So if we use cotton, we could use a certain overlay for every fabric to determine the specific count. We must be sure to place the overlay in the right direction. We should have the right alignment when we are counting warps and the right alignment when we're counting wefts. And in more complicated fabrics, the overlay didn't provide us with the actual count, with the actual thread count. In that case, the measured count should be coupled with the geometrical approach to compute the actual count. In fabrics like the Oxford cloth, we can do this for every type of form of Oxford cloth. It will be square root of 2. But in some other types like denim, we should have a different approach at its different denim fabric. So this is my reference. Thank you for your attention.
Thank you. It's time for questions for our opponents.
So, hello ladies and gentlemen, my name is Bogdan Ryszewicz and today I propose the task number 13, Moire and R5S3. So, please, could you show me the first slide where you use the overlay on the lines? I would like to see more about that.
Where I'm talking about the importance of the right alignment.
Go next.
This one.
No. Go. This one.
This one. Okay.
Yes. I can clearly see the two interference.
So
one is about 47
So you're talking about
and one is about 37.
So you're talking about interference like that?
Yes. So which one did you take? Because
so actually these curves are a result of the Moire fringes created by the interference of the computer in our picture. There were no interference here. It's just the way that the computer displays it, because even the display of the computer is a Moire fringe.
I absolutely disagree. Thank you very much. Could it be one of the solution for the problem where you had the cotton and it was doubled, like the measurement was 2 times lower or 2 times higher?
So whether there could be a formula to compute every time? Whether there could be a formula to compute every time?
You use this pattern, and according to your Moire pattern, there was 2 times lower number of threads. So could it be used this formula?
No, actually, what I'm trying to tell you is that there is no problem here.
Okay, we will analyze it in the.
Okay.
How did you measure how really these threads are? What is the distance between your thread? Did you use the microscope or any kind of photo?
Well, in every type of thread that we use, we know from the industry what the actual thread count is. So we wanted to test the accuracy, so we use the actual number to see how accurate our model is.
Okay, thank you. It's time for the preparation phase. Your position speech, please.
So, hello ladies and gentlemen. Again, my name is Bogdan Ryszewicz, and today I propose the task number 13, Moire thread count. So, the problem statement clearly is about accuracy of the system, and I believe that the accuracy wasn't truly investigated. Also, they should have design and overlay. Well, they design and overlay. However, I have seen these overlays on the internet a couple of times, and therefore I don't really see that this is their own contribution, but they used it, they maybe optimize it. I don't really have an idea, but well, they used it and it was fine. So this entire presentation, the first thing was about defining what exactly is Moire, why do we see these Moire characteristic of fringes, and it was pretty explained. Then we have seen this design and its usage. However, we didn't really see any real experiment. We didn't see photos of used Moire pattern, and I believe that this could have been some nice pictures, would be nice to have. And also their experiments, I believe they were poorly done. Well, I think that they determined accuracy by counting threads in some distance. I have no idea what was the distance, whether it was 80 threads on 1 inch, or why did they use the table values. And I believe that they, in my opinion, they could use, for instance, photos or maybe microscope if they would like to go even further, in order to reliably calculate how many threads there are. Also, I didn't really see how accurate their pattern was in order to some differences, such as changing the angle of their sample. They told that their overlay is sensitive on the angle, and I believe that it is true. I have also the proof of that. However, we don't know how accurate they were by using truly the parallel lines. Also, we don't know how many times they repeated the experiments, and I think that this should have been done because we could get some other results and therefore calculate the accuracy, the real accuracy of the system, because there were sometimes accuracy 50%, sometimes 100%, so this could deviate. Also, as I said before, I believe that this Moire pattern is truly sensitive on the angle, because we can clearly see that when we do just some parallel lines and change the angle between these lines, the distance between Moire fringes changes a lot, clearly. Also, they didn't tell how is their method reliable when they change the width of the lines, the distance between lines, or maybe the color of their sample where they applied the Moire pattern. And I believe that this could be more investigated, at least qualitatively. So now I believe we can move on to this discussion. So, firstly, I would like to ask you about your Moire. You use simple hyperbole, as I believe, and due to the when your lines, your sample interfere constructively, you didn't see the Moire fringes character.
No, actually, the resolution of the computer is actually composed of parallel lines.
Okay.
It's the pixels. So there are pixels right here, and our overlay, the way it is displayed in PowerPoint, interferes with the computer resolution.
Okay. Yes.
In reality, it's just the lines.
Yes.
It's just the lines.
Yes. I agree. But what if you? But it also could interfere with the multiple of your lines, because if you would have, here's 40 lines per inch, and okay, your sample could have 40 lines per inch, but it could have also 80, because it could constructively interfere with multiple
Every second inch.
Yeah, and there wouldn't be Moire
Okay,
observer.
that's true, and that's what happens in coding experiments, and that's why I also proposed a method to optimize. It is to limit the range to be close to the actual range, so just to limit it so that so as to find the.
Okay, but could this happen for some other fabrics you've used? This could have happened or not?
Yeah, this could have happened.
Okay.
So we can optimize it by limiting the range of our overlay.
And how did you know where you should limit the range? Because this is also the part of the task is accuracy. So your theory, your overlay is applicable only to some extent.
Yeah, well, there are two things we could do. The first one is to limit. So in the fabric industry, for example, columns have specific values of thread count. So we could just design an overlay that has the range. But that's
okay.
case.
I believe that this method should be applicable for. Well, it should be used like a measuring tool. So before measuring, we shouldn't have to find some table values for thread distances.
So
therefore, I don't believe that this isn't really.
As I said, we have two methods. So the second method is just to see how strong the Moire fringe fabric is. So maybe
how strong? On what does the strongness of your?
Because the strongness is dependent on the. Because the strongness of the Moire fringe is dependent on the difference between the distances.
Okay, that's one parameter. I believe that. What are the next parameters that you should have taken into account?
Well, what I'm saying is that if we have a weak Moire pattern, but we don't have any other Moire pattern in our overlay, that means that our pattern is out of range. So with the strongness of our Moire fringe, we can understand whether we must use a different range in our overlay.
Okay.
In the current example where we had half the actual count, indeed the Moire fringe was not that strong.
Okay, so it wasn't reliable because it wasn't strong.
Yeah, we actually saw that it wasn't strong. So we repeated the experiments with the other.
How reliable is your action?
For simple fabrics like linen, mako, and cotton, it's very reliable. At least if we ensure that it is within range.
Okay.
So we can use it for a lot of different types of fabrics.
Okay. What if I give me one fabric that was reliable for you?
Reliable. So mako.
Okay, mako. And what if I would give you mako, which have some threads? But let's say that 5 of these threads in a row would be black, and 5 of them would be white, and it would change, or there would be change of the color of this.
Well, because I referred specifically to mako, there is a special way in how fabrics are woven. So I think this would be a different pattern, because if you think about it,
no, it would be the same pattern with the different colors of the threads.
Well, actually, the Oxford cloth is just another.
No, I'm asking about mako.
Yeah, but I should give an explanation using another example. That's what I have in mind, so you will understand.
Okay.
For example, the Oxford cloth is a series of vertical lines and horizontal lines.
No, I'm asking about
thank you. Please give me the chance to talk about that. But it's the color that creates this diagonal line. So again, in the mako, if we painted them in different color, then it would be a different design, a different fabric. Because
it would be still the same fabric, just with the different colors.
I mean,
not with the same distances between the threads.
Yeah, that's true. But I'm talking actually about the textile. I'm talking about the type of fabric. When we're talking about mako, we don't talking about this design where it has colors. Then it would have a different name.
Okay, so then the mako wouldn't be reliable. Like the accuracy for macros would change. We should couple that. Yes, we should couple that with a geometrical approach, as we did in the Oxford cloth. Where actually the Oxford cloth, Oxford is not a textile; it's just the design. So yes, that's what I'm talking to you about. This would be mako as a textile, but it would be a different design. So again, in the mako, our method is reliable. Okay, so now I would like to state that yes, they told in their presentation that the mako is reliable, but now we have proved that maybe it wouldn't be as reliable if we would change the parameters.
Excuse me, but macro would be reliable.
No, it wouldn't be
For
macro.
different colors. It wouldn't be macro. It wouldn't be called macro if it had technical.
No,
because Oxford code.
Okay,
It's just a design.
I think that we can.
Then we could use the term column for the Oxford code.
I don't think that this has a result. Okay, so you said that you use the table values.
So you mean
For them, you use the table values.
Yeah.
So you have found that there is some number of threads per 1 inch or per 1 distance.
For 1 square
And it
inch.
was okay, and it was absolutely the same for. No, it was a bit different for your.
For the actual count?
For your actual results from the Moire, or not? Was it different?
No, there was no mistake. So can you go to the slides with the results 34 plus 34, for example, all these slides, but the first ones, please. So yeah, I know at least some slides more.
And why didn't you count it by your own? Why didn't you use the microscope or anything different? Why did you choose the table values for fabric you've been using, and you didn't have the table values for that exact fabric as I think so? Maybe did you have for that exact fabric?
So you say why I compared it to the
Yes,
actual
because
breakdown?
I think that if we want to have some reliable method, the first we have to accurately measure distance between those threads or density of those threads, but with some really accurate method. Well, for instance, photo or microscope or something, not table values, because I don't think that we can rely on the table values, and then we compare results.
Can I say my opinion about
Yes,
that?
you can.
I think that this is irrelevant because the problem definition is to design an overlay that allows us to measure.
And
So,
that's not
excuse me, can I please end my point? Okay, so we must use an overlay that allows us to measure the actual count. It doesn't state how we should measure the actual count. We just want to determine the accuracy. How we define the actual count is just another matter. And so
if we want to determine the accuracy, we have to firstly see what is the actual distance or density of tracks.
Yeah, but whether we use a photo or a microscope, like you said, or whether we use the actual results from the fabric later on it, I think it's the same. We just want to measure the accuracy of the fabric.
And according to my slide, do you believe me that this tilted angle, that it is
it is
sensitive to the angle?
Yeah,
Is
of
it or not?
course it is sensitive.
And how did you make sure that you use the exact parallel pattern to your lines? How can you be sure? Short answer.
Okay, yeah. Here we have a vertical line where the fabric, imagine that this is fabric where the fabric ends. So we must align it perfectly with the vertical line so that this line is horizontal to the alignment of the works.
Okay, time is over, so let's go to the conclusions of opponent.
Okay, so I think that in my opposition we have proved that maybe his method is not truly reliable, because if we would change angle just a little, there would be clearly seen that there is the difference in the Moire. Also, we wanted to touch the accuracy of their system because we believe that it could really differ by using the table values, and maybe they should move a bit further and use some more advanced and reliable methods such as photos and microscopy. We have also shown that their Moire pattern using the hyperbolist, it might interfere more times, and we didn't really see what was their limit, with which distances they were counting. And therefore, if we would use really long pattern, maybe we would see more Moire. Thank you for your attention.
Let's proceed. Questions from the reviewer.
Okay, so quickly to the reporter and then the opponent. Very quickly, how do you define a complex fabric?
So, can you start?
Yes.
Well, a complex fabric is a fabric where the most prominent lines are not the horizontal and the vertical lines, the warps and the waves, but maybe the diagonals.
Thank you. Just one degree.
Well, complex fabric could be defined by different angles between threads and also the different color of the threads.
Okay, thank you so much. And to the reporter, how did you analyze the Moire fringes? So when you put your overlay and you get your pattern, how did you measure to get the thread count? What was your analysis?
Well, as you can see, there is the Moire fringe becomes almost infinite, where the distance means the actual distance. So where the Moire fringe becomes infinite, that's where the thread count is.
So you just had a scale and used it as a ruler, is that it? Or is it?
Yeah, that's good.
Does the reporter think, does your opponent think this is a good way of analyzing?
No, because I think that this infinite distance between Moire can occur many times, and it also is very sensitive to parameters such as width of the lines and angle.
And to the reporter, you said this many times in your speech and discussion. What limited the resolution of your overlay? What limited the resolution of your overlay? You said that your overlay was limited to a specific scale.
Well, actually, I'm talking about the computer resolution, which gives me an interference pattern right here. You can see some waves, and
Okay,
and there's all of the interaction with.
thank you. And so the limit to, so you can make the overlay as any resolution as possible. Is that right? Yes, yes. And what was the resolution of your printer? In dots per inch or in lines per inch? The resolution of your, do you know the resolution of your printer?
Of my printer?
Yes, that you made to create the Moire printer. Do you know, yes or no?
Yes, I know.
What's the number of your printer resolution?
Oh, I don't know.
Okay, thank you so much. And how did you define the thread axis? When you put your overlay down, how did you define that this is the axis, not tilted by 2 degrees, 3 degrees, or 4 degrees? How did you define the thread axis?
Yeah, well, for example, let's use that here. Let's say this is a fabric, so this is a vertical line, and we just have to align it horizontally so that it is
Okay, give me a question.
vertical to the.
So you measured it at one spot, correct?
At one
So you
spot?
just measured, you put overlay down and you just use that data that you got, correct?
Yeah, since it is the same in every place.
Thank you so much. So to the opponent, do you think there's a better way to differentiate between the effective lines and the diagonal to the real lines, which were the horizontal?
By using the
Using the
well, firstly, we would have to really measure what is the distance between lines, and then we could set the limit for our, let's say, ruler. However, I don't believe that this method is truly good for Moire.
Okay, time is over. Proceed with the preparation.
Good afternoon, everybody. So my name is, today I'm going to be reviewing the problem of Moire thread count. So the problem statement is, when a pattern of closely spaced non-intersecting lines is overlaid on a piece of woven fabric, characteristic Moire fringes may be observed to design an overlay that allows you to measure the thread count of the fabric, determine the accuracy of what simple fabric such as linen, and investigate if it's reliable for more complex fabric. So the conclusion that task we give the reporter partially fulfilled because it is, as it is experimentally shown, it is ineffective in actual thread counting and in practicality terms. He did not define the complexity of cloth, which would be is that a cloth is complex when the thread count does not match what you see. For example, the opposite, where you have to multiply by 2 to get the actual thread count from what you would measure. And lastly, he did not provide the methods to identify the effective lines. Next is for the horizontal line, he talked about the definition of the Moire pattern, and then talked about the large scale interface, the mathematical model for Moire fringes, and then said that the total thread count is the horizontal count plus the vertical count. And he said the overlay, when the pitch is identical, the wide fringes will be produced, and this can be experimented. This can usually be thread counted. For experiment, he used linen and found it was equal, macro which was equal, and cotton which was half of the actual. Next, for the complex fabric, he found that for the oxford was square root of 2 less than usual. This is a weakness of him because he could just tilt the pattern by 360 degrees, and there would be you'd have 2 sets. The horizontal one and the diagonal ones. The diagonals would always be larger. Experiment, the gentleman found it was 1.2 times off. For experiment, he came up with a math model to elaborate on the phenomenon, talked about a different fabric being used. For the weakness, he did not define the complex cloth, did not provide enough method to identify the effective lines, was not objective in defining the thread axis, had bad significant digits. He only had 66, not 66 points, and so on. Did not show actual experimental results. Did not show the methods of analyzing. No experimental photo, no on-contribution, and bad time management. For the opponents, the strengths is that he pointed out the lack of visual results, good understanding of the phenomena of the problem. Weakness is that he did not ask about the deformation of plots, and he talked about the weakness of the but however he did not have any suggestions at all. So opponent's speech is that he talked about the summary, he gave partially fulfilled, for the discussion was the pixels grid on the screen causes for the Moire pattern. We would agree with the reporter, however, he did not show how to differentiate between the pattern from the fabric and pixel. This can be done just by simply rescaling the image on the computer, and the pattern from the fabric will stay the same, the computer will change. Next is the Moire pattern that appeared every multiple value of the actual value. I would agree with the reporter in this one, is that we could increase the resolution to 2 times to verify the account. Next was the different color of the macro. The opponent said the accuracy of the measurement of macro would change and not reliable for the parameter changes. We partially agree with the opponent because the color would only make the pattern harder to be seen. It wouldn't change any the Moire fringes itself. For the use of thread count from the table value, we would agree with the opponent is that he should have measured himself, so he would get 60 point something and so on, so digits. And for the missing point was the orientation misalignment, limitations of the overlay, deformation and stress, so he should have should have measured different points of the plot to take into account the fabric deformation, which is something we should assume in every fabric. The resolution of the printer, which he did not know, this will limit actually the scope, the resolution of this overlay, and the more pattern from the detector pixel, the more from the computer screen, the parallaxing pattern. They did not discuss if the pattern was overlaid like 10 centimeters from the fabric, what would happen. Theoretically, they did not define complex fabric well enough and did not talk about the resolution of the device. Thank you.
Okay. Let's go on with final.
Okay, so I've had a nice discussion with the reporter, and I appreciate the remarks by the reviewer about resolution, although I think that it doesn't really change how the experiment is conducted. So I determined the accuracy for simple fabrics, and it was very accurate. It was 100% accurate. And about the unoriginality of our experiment proposed by Sweden, I think we should just find the most convenient design, the most scientifically right design, rather than a very impressive design. About changing the angle, yes, it can change the result, and that's why we talked about the proper alignment. We provided an optimization about limiting the range of the fringe. We repeated a lot of experiments, so our results were truly accurate. And I actually provided a method to measure the actual thread count from the measured count for a complex cloth. For example, the Oxford cloth, that's the square root of 2, the method. In other fabrics like the denim, well, there you just cannot define the actual thread count from the measured thread count. That's why our overlay doesn't work in denim. And I think most overlays wouldn't work in the denim because it's different. Every denim is different. And about the macro discussion with opponents, it won't be a different textile. Macro paint is black and white, will still be a macro, but it will have a different name as a design. Because the Oxford cloth can also be cotton, for example. But we call it Oxford cloth because it has a different design, and as you so we had different accuracy for the Oxford cloth and for the cotton. So we should be careful when we're talking about textiles. It's a different textile and it's different design of the fabric. And that's what we're testing, the accuracy for different designs of fabrics, not for different textiles. And we don't need expensive instruments like microscopes to test the actual thread count. We just have the label on the fabric that tells us what the actual thread count is. We just want to measure the accuracy.
Thank you so much. Let's proceed with the jury questions. Okay.
Also, you said the results were very reliable. What do you mean by that? Can be some...
Okay, well, provided that they are within range, and we talked about ways to limit the range, it would provide us with 100% accuracy. So, for example, in the lining, we had the accurate count.
Thank you.
If I could add to that.
Yes?
It's only accurate because the significant digit, he did not have any decimal point. 60 and 60, but perhaps maybe 16.1 and 16.9. So that's why he had. I agree.
Okay, thank you very much.
Okay, further questions? Go ahead.
Can you show the slide where you have your overlay?
Yes.
So so the question is, if that was a real Moire pattern, what would you say was the thread count?
Thread count. So yeah.
Maybe for the reviewer and opponent first.
Okay, so if I can start. So we're going to take it from the point that the reporter said as soon as the pixel. The pixel is going to be arranged in a very complex way, so it's not going to have one axis.
No, I mean just pretend that this is a real
Result.
Yeah.
Well, the real result, you're going to have to use the maximum one. If it becomes 40, 20, and 10, 40 is going to be the correct one.
What about the opponent?
Well, I believe, yes, I agree with reviewer, because even though reporter said that this happens only for pixel, pixels are in the rows which are also in the real fabric. Therefore, it must happen for
So that means it's 47
Yeah,
and not the 31.3.
Oh,
Can it be something else other than this?
well,
If I could add,
Yes, it could be something else. Like we must limit our range, because if we always knew that this is the range we want, then yeah, it would be like this is the strongest range, so yeah, it would be 47. But if it's not the right limit, then we should use a different overlay.
Could it be double of that?
Yeah, maybe the double.
well, we have to use the most visible pattern, which would be created by Moire.
if I could add, I would actually disagree with the reporter because he said to limit. I would say to expand the scope of resolution. Because if it's a 40 thread count, it's going to happen 20 and 10, but not at 80. So he has to increase it to 80 to verify that it's not 80 and 40.
Excuse me. By limiting, I mean choosing a different overlay. Maybe it's not the right word, but I mean the same as you. I just use the word limit to say that we use specific values, right? Some different values have more values. Yeah, definitely.
Okay, further questions? Gabor?
Okay, so if you have the simple pattern, the simple textile, and you put your lunometer, you also your overlay on this textile, and what is happening with this hyperbolic structure if you rotate the overlay?
Okay, so as you can see, if we rotate it so if we rotate it only bit, this would be the resulting Moire range. But if we rotate it a lot, then there will
Only
be
a little bit. What is happening? Only go back to the original. Oh, this one. Okay, yes. What is happening if you only a little bit?
If we
A little bit. Rotate only a little bit. What is happening with this hyperbolic structure?
If you
Little. Only a
just
small angle.
a small angle. So yeah, I think this is the same. You can see it's just the same.
Okay.
It's just a small angle, and there's a difference in the.
Yeah.
Well, I think that this is not really the small angle, because as
Yes,
I've
and-
shown, it's truly sensitive.
Okay.
So there will be different.
If I could add, this is what I meant in the report where he said he was very arbitrary in defining the thread axis. So using this meant that he could not objectively define the thread axis. If you rotate it by, say, very little degrees, you could not differentiate by the actual 0 degrees.
Well, can I just very briefly answer to that? Well, here we can see that there is a problem. So we just align it so that it will be the same line. I don't think there will be a problem.
Okay. Thank you.
Okay. Can you also go back to the page where there are two figures? I mean, figure 2 and 2A. Yeah. 3. Oh yeah. That one. Is this yours or from the literature?
Well, actually, this specific picture is from literature. I will reference that in the end. So.
Okay. Any further questions? Thanks again, presenters. And we need a moment. Marks for the reporter. So, it is 4, 6, 5, 4, and 4. Let's proceed to the opponent. So, it's 6, 7, 5, 6, and 6. And finally for the reviewer, we have 8, 8, 8, 9, and again 9. Okay, so let's have a talk about marks. So we have a couple of scores for the reporter. Gabor, can you explain yourself?
Yeah, so my final score was 3.6, so not great, not terrible. And okay, so you show only a few pictures of your setup. It was hard to believe that you make the measurements. You show on pictures from the fabrics. And I also expressed some theory that you show the hyperbolic lines and you plot these hyperbolic lines on your pictures. So this was more missing points for me.
Can you also comment on your partial points?
Yes, it's 1, 1.6, 1, 0.
So, excuse me, can I ask you a question? Which hyperbolas are you talking about?
This hyperbolic structure.
Which point of my presentation? Excuse me, but so that you understand.
Okay, we will discuss it after this.
Okay, thank you.
Okay, and we also have 6 from Paul. Can you comment on that?
Okay, so I understand that the problem is probably not done very completely. There were many points which the reviewer has also brought up, that there are things which could have been improved upon. But I like this presentation very much because I felt that the explanation was clear. I mean, at least to me, it was very clear. You gave good examples. You have shown the pattern of the cloth under the microscope, although you did not measure, count the threads and so on. But it's obvious you have taken the pictures of the cloth to show the structure, and I like the idea that you have also shown some of your results, the raw data, which leads you to come to the calculation. So for me, the report was good because of the clarity of the phenomenon explanation. The thing which I scored lower was the discussion with the opponent. In this case, you did not seem to say a lot. Yeah.
So could you illustrate this with your partial grades?
So I gave 5 for the report, and I gave 1 for the discussion with the reporter, and then I subtracted further 5 for the answers.
Okay, I think we can proceed to the opponent, and there is place for Zakar with your 5.
Well, I appreciate your questions and the topics you brought, so I like them really, but still the thing which brought your mark so low for me was your attitude to the reporter. So that was so negative that was really you tried to find out the flaws even where there were no one of them. So the whole speech of yours was started from the thing that something was not done, something was really bad, and even where the green spots appeared in your presentation, there was not full something, and you didn't talk about any positive side of this report. And the same with the polemics. It seemed to me that you tried to find something with what you can disagree. That was the main thing which you tried to find. That was for me very.
Could you picture this with your partial points?
Okay, so I gave you 1 for the questions and 1.5 for the speech and 1.7 around for this polemics.
So, Paul, can you also say a word about your 7?
Okay, so I felt that you did have some good points. I also understand that the reporter has not done many things which they could have done. So I think it's good that you have pointed out these things. So I gave 0.5 for the questions asked. I gave 3 for the speech. And I gave 2.5 for the discussion with the reporter. And that's it.
Okay, thank you. And we can move to the review. And I was one of those who gave you 8. So why 8, not more than that? I find your points very clear and well related to the subject. I give you some extra points for missed point that you brought out. But when talking, for example, about the accuracy of that method, you did not really define what you mean by the accuracy. You also, of course, you talked about the digital, the uncertainty in a sense, the valid digit numbers. But you should make yourself more clear on what you mean by uncertainty of that method. And of course, this problem has also stated that you have to design a pattern and try to improve that pattern. You did not really bring this to account as well. So this is why I was among those that gave you only 8. So my partial points were like 1.25 for the questions, 2 for the review of the reporter, 1.5 for the review of the position, 1.25 of the discussion, and I add you extra half a point for the missed point you bring in. And Susan, can you also give...
That's one of the best reviews I've seen in this competition, so I was very impressed. I think you covered everything really very well, and I gave consistently high marks than I have been given, so well done.
Can you also bring...
I've got a 1.5 for the questions, 2 for the review of the report, 2 for the review of the opposition, 1.5 for the discussion, and 1 for the missed points. So, well done.
Okay, so I think we can once more thanks for the entire fight. It was a good work.